All right, so in the last lesson, we talked about what normal was as far as distributions, and we did some estimating of the distribution. Now what we're going to do is we are going to learn how to actually do it a little bit closer to what's going on instead of an estimation. We'll be able to find the exact type of value more precisely. So there's a rule that's called the 68, 95, 99.7 rule. And what that is that about 68% of our data, or about 2/3 of our data, are going to be within one standard deviation from the mean. And then 95% of the data will be within 2 standard deviations of the mean. And then about 99.7% of the data will be within 3 standard deviations of the mean. So let's go look at some pictures. I realize these did not print out very well. I'll make them dark before I put it up on D2L. All right, so here is a picture. So we're looking at 68% of the data is right here in the center within 1 standard deviation. And then if we go 2 standard deviations, 95% of our data will be between that 1 and 2 standard, or between the 2 below and the 2 above standard deviations away from that mean. Remember, our mean is right there in the middle. And then 99.7% of the data is going to be within 3 standard deviations. Now that means there's this little bitty spot, because that's not 100%, that's going to be over here or over here. Okay? We can also break that out a little bit further. If we have 68%, that means half of 68, which is 34%, will be here. The other half is going to be right here. So we can figure out some of those values a little bit further. Now, we said that's 68% of the data, right? So 68 divided by 2 is 34, so half on the lower side, half on the upper side. Now, if I take, and I do a little bit more, now 95%, if I take 95, because that's 95%, and I subtract out 68%, that leaves me with 27%. So the 95 is the second, right? The second standard deviation would be 95. And we'll talk about this a little bit more coming up. I just want to give you an idea. All right? So 68%, then 95. For the 95 part, let me do a little bit of writing stuff out. So 68% divided by 2 gets us 34, right? So 34% is above and below the mean. All right? Now, if we take 95% and we subtract out the 68%, because that's in the first chunk, then that leaves us with 27%. Now, if I take that 27% and I divide it by 2, I get 13.5%. And this is going to be above and below as well. So this is where I'm getting 34% on both sides, and then that 13.5% is going to be above and below. It just won't be above and below the mean so much as above and below that 68%. Does that make sense? I hope it does. Now, if I take our 99.7% and I subtract out 95%, yes, right? Yes, sorry, processing. That will get us, what, 4.7%? Let me make sure. Yes, so 4.7%. Now, if I take 4.7%, then that will be divided by 2. That will get me 2.35%. Okay? Now, what we haven't talked about is then the other 100% minus that 99.7% will get us 0.03%. And if I take 0.03 and divide by 2, I will get 0.15%. Oh, it's not 0.3, so sorry. So 100 minus 99.7. I'm like, something doesn't look right. So that shouldn't be, so we'll take this 0 off and we'll put the 0.3 there. So 0.3 will get us 0.15. Sorry about that. All right, so we've done this. Let's go back and look at our deal. So 68% of the data is within 1 standard deviation. 2 standard deviations is 95. 3 is 99.7, and then the whole percentage under the curve is 100%, right? Or same as 1. All right, so I split the 34, or the 68 in half and got 34s. I subtracted the 68 from the 95, and I got 27. So 27% is in these two parts, but half is below, half is above. So I split 27% in half and got 13.5. So the data up to this point is 95% because it's 1, 2 or 1, 2 standard deviations away. I subtracted that from the 97%, which gets us at the edge of our curve here. And what's left here, after I take out 95%, that part there in, it's always hard to, that part here and here is 4.5% of the graph. So if I divide it by 2, this is 2.35%, this is 2.35%. And then if I look at 99.7% of the data is here, there's a 0.3% that's left, so half is below and half is above, so it's 0.15%. So I'm hoping this gives you a bigger feel as we go forward, and we're going to do some math things like we did in the previous section, but we're going to use a little bit more going on there, okay? So this is a concept that we're going to talk more about because that's a big chunk of what we're looking at. All right, so let's go look at our example 1. So there's a test of depth perception is designed so that scores are normally distributed with a mean of 50 and a standard deviation of 10. We're going to use the 68, 95, 99.7 rule to find the following values. All right, so we have a mean of 50 and a standard deviation of 10. So the first thing I'm going to do is I'm going to draw a number line. I'm not going to draw the curve, but I am going to make a number line. And in the center of my number line is going to be 50. This is our mean. Okay? And then standard deviation is 10. So what I need to do is I need to take 50 minus 10 gets me 40. And then I'm going to go ahead and do 3 subtractions. Minus 10 will get me 30, and minus 10 will get me 20. So 1 standard deviation below will put me at 40. 2 standard deviations below will put me at 30, and 20 will be 3 standard deviations below the mean. All right, so this is 1, 2, 3 standard deviations below. Now, I'm also going to mark where I will have 1, 2, and 3 standard deviations above my mean. So to get to there, I'm going to add. So I'm going to have 50 plus 10 will get me 60, plus 10 will get me 70, and plus 10 will get me 80. So again, that's going to be 1 standard deviation, 2 standard deviations, and 3 standard deviations above my mean. So that'll get me 60, 70, and 80. So this is 1, 2, and 3, and this is 1, 2, and 3. Those are the amount of standard deviations from the mean. So you're going to add and subtract the standard deviation from the mean, either adding up, subtracting, going down. Now, what we just talked about is that within one standard deviation, the group there, that's where 68% of our data will lie. And then within 2 standard deviations, this will be where we'll have 95% of our data will lie. And then our third standard deviation, 99.7% of the data lies within there. So this is how we're figuring out what we need to do. All right, so we've got to figure out this part so I can answer the questions. All righty. So the first question, part A, it says the percentage of scores that are less than 50. So 50 is our mean. So what percentage of scores lie down here? Well, if 50 is our mean, that's half of our distribution, right? So that's going to be 50%. Because that's where our mean is. Okay, so it's still 50% above and 50% below our mean in our normal distribution. All right, let's look at B. So for B, it says the percentage of scores that are less than 60. All right, so we're looking at the percentage of scores that are less than 60. So that means 60 and below. Now we already know that 50 was 50%, right? So we just got to figure out this little chunk here between 50 and 60. Well, that's one standard deviation, right? It falls into the 68%. So let me write some clues here. So 60 is one standard deviation away from the mean. So it's in the, so it is in the 68%, right? It's in the 68% of the grouping. 60 is. We'll get back to the less than, but 60 is within one standard deviation. But I only need this half because I'm going to take this whole half down here, but I need half of that 68. So that's where we're going to take 68 divided by 2 will get us 34%, which is what I was talking about in the beginning here. Half of that 68 is going to be 34% of our data. So I need this 34% here and the 50% down here to get all of the data from 60 and below. So that's going to get me 34 plus 50 will get me 84% of the data is going to be below or less than 60. So that is our answer right there. All right, let's go to the next one. So C says the percentage of scores greater than 70. So we're looking at greater than 70. So where does 70 lie on our diagram? Well, 70 is within 2 standard deviations. We want the part that's greater than 70. All right, so 70 is 2 standard deviations away from the mean. So it is in the 95% group, right? So we're looking at that 95% category. Now, in this case, we are looking at greater than 70. So let me make a note up here. So this was less than 60. And the first one was less than 50. And this one is greater than 70. So we can keep straight of what we're doing. So greater than 70. So I want the parts that are above here, right? The whole thing. So if it's greater than 70, and 70 is 95% of our data, right? So if we're looking at 95% of the data is here, the other half is going to be above and below. So we could use the diagram that we did before, and I'll show you, or we looked at, but I'm going to show you this first. So if 70 is 2 standard deviations away from the mean, and so that is included in the 95, what I can do is take, instead of splitting that, because I've got to figure out what's above it, not this part plus the 50, like we did on the previous one. I have 100% of the scores on my graph, and if I subtract out 95%, I'm left with 5%. Okay? So that means that there is, let me make this just a little bigger here, 5% of my scores are outside of my 95%. So 5% land in these areas here. But that means half of it is up here and half of it is up here. That's equal to the 5%. If I take 5% and divide by 2, I get 2.5%. That means 2.5% is up here and 2.5% is down here. That's one way to figure it, which is the typical way I would do it. Now, what we could do is if we have, and we understand how this works, if I'm going above 2 standard deviations, here's 1, here's 2, that means it's this part up here, right? So the 2.35 plus 0.15, that'll still get you 2.5%. So either way you want to look at that, you can add these two parts. If you understand this, you can say, hey, it's above that, you know, and I'm going to subtract the 50 and these two parts here, but to me it's a little more complicated. You'd have to subtract out the 34 and the 13.5, which to me is a little more complicated than just subtracting 90 and then dividing 5 by 2. So figure it out, play with the numbers, and kind of go where you're at. To me, this is easier. So this is usually the way that I go with this. So 2.5% of our data is landing above greater than 70. All right, let's go look at part D. So part D says the percentage of scores greater than 40. So greater than 40, that means 40 and above. Well, 40 is within our 1 standard deviations, right? So between 40 and 60 is 1 standard deviation. So we're in that 68%. And we're looking at greater than, so what we're going to do is write what we know here. So 40 is 1 standard deviation away from the mean. So it is in the 68% group. And again, we've talked about 68 divided by 2 will get us 34%. So if we're looking at 40, half of our data is 50 and above, right? So 50 and above is half the data. And then we have to include that half of the 68%. So 34% lies here and the rest is up there. So we are again going to add 34 plus 50 will get us 84%. So it is the same answer that we got before, but we're looking at the data a little bit differently. All right, our last part, part E, says the percentage of scores between 40 and 70. So E is the scores between 40 and 70. All right, we just talked about how 40 is 1 standard deviation away and 70 is 2 standard deviations away. So 40 is 1 standard deviation and 70 is 2 standard deviations. We go back up to our graph, we can see that it's 1 within 2 and this one is within 1. So that means for the 1 standard deviation, it's going to be 68 divided by 2, which will get us 34. And the 70, that's 2 standard deviations, is 95 divided by 2. Oh, we haven't done that part yet. That'll get us 47.5%. Because we're looking at, now I know you're like, but wait a minute, that said 34 and 13.5. That's because this is a little more detailed. But if I only cut that in half, the total of these two is 47.5%. Okay? So, I'm going to then add 34 plus 47.5%. And we will get a total of 81.5% of our data is between the 40 and the 70. All right, so our next part that we're going to look at, and you're going to have to play with this a little bit. If you have questions, then message me. Maybe we can meet and talk, because some students kind of struggle with this a little bit. But you'll also have homework in it, and you'll have an activity, and that practice will help you understand it even better. All right, so let's go on to example 2 after we look at a little bit more information here. So we're going to compute standard scores. The number of standard deviations a data value lies above or below the mean is called its standard score, or the z-score. It's defined by z is equal to the standard score is equal to data value minus the mean divided by the standard deviation. So this is what it will look like. And I see that some more of the graphs didn't. So the standard score is positive for the data values above the mean, and it'll be negative for the data values below the mean. So the pictures that did not show up, I have to do a little bit more tweaking on that. These are our negative scores. This would be our positive. So below it'll be negative, above it's going to be a positive score. And it's measuring the area under the curve there. Okay? All right, so for example 2, the Stanford Binet, or Binet, I'm not sure, IQ test is scaled, so that its scores have a mean of 100 and a standard deviation of 15. Find the standard scores for IQ scores of 85, 100, and 125. All right. So we're going to go do some math. So this will be example 2. So for example 2, we've got our z will be equal to our data value minus the mean over the standard deviation. All right, so the data value that we were asked to do is the 85. So the IQ scores, those are the data value. The mean is 100 and the standard deviation is 15. So we're going to take our data value. So this is z equals the data value of 85 minus our mean of 100 divided by the standard deviation of 15. So on the top, we will get negative 15 divided by 15 will get us negative 1. All right. Our second score that we were asked to find was a score of 100. So we'll have The 100 is our data value minus the mean of 100 over the standard deviation of 15. So 0 divided by 15 is 0. And then the third score we were asked to find was for 125 minus our mean over our standard deviation, which will get us 25 divided by 15 over, which will get us 1.67. So these are the answers to finding the standard scores, the z-score. Now there are tables that help us compute our z-scores. So we can convert standard scores to percentiles with the computer software or a standard score table. So here's one part of the score table, and on the back is your second part on your handout. I have an actual side-by-side for us to look at here. So these are the z-scores. So this is, this one is from 0 to 3.5, and this one goes from the negative of 0 to the negative 3.5. The way you read z-score tables is you take the first, like up to the first decimal over here, and the second decimal will go here, and then you like bring it together to read it. And the same thing would be here. And I imagine we're going to practice that in a second here. All right, so let's go look at example 3. So example 3 says to use the standard score table to find and interpret the percentiles that correspond to the standard scores. First one is negative 1.7. So this will be example 3. We have negative 1.70. So that means we have to come over here to our z-score table, and we need the one with the negative. I go down here to negative 1.7, and here is the 0. The second decimal place is what you're looking at. And it gets down here to 0.446. So 0.0446. All right, that's our value because negative 1.7 and the zero's right there, you come straight down. So we get 0.0446. Now, if I want to change that to a percentage, we are again moving our decimal place 2 places to the right. So I'll get us 4.46%. That would be our answer. Now for part B, we're asked to do the same thing for 0.15. So it's positive, so I'm going to go over to this table and do the positive. So 0.1 goes here, and the 0.05 is here because I need 0.0 or 0.15. So 0.1 is here. It does the first decimal. The second decimal is here at the 5. So I have to come down to where I'm across from the 0.1, and I get 0.5596. So I get 0.5596, changing that to a percentage. I move my decimal place again, and I get 55.96. All right. So that's how you use the z-score table. You just got to match it up. So our next example is example 4. It says cholesterol levels in men from 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. What is the percentile for a 20-year-old man with a cholesterol level of 190? All right, so this is example 4, part A. So we're looking at the same thing we did a minute ago. We're going to find our z-score. So we're going to find our z equals, and remember that's going to be the data value minus our mean over our standard deviation. All right, so Z will be equal to, our data value is 190, our mean is 178, and the standard deviation is 41. So 190 minus our mean over our standard deviation. Now, when you're doing these, you want to make sure, I didn't mention this before, but you want to actually do the subtraction. First, you want to show it to me. And second of all, if you don't do that and you don't put parentheses, the calculator will take this number minus that one divided by that. So it's best if you step it out. This will get us, this will get us 15. Sorry, I'm looking at my math and I have a negative sign there and I'm not sure why. And then 15. No, that's not even 15, is it? All right. Something happened with the math in there. All right, so we have 190 minus 178. This is why we do partial credit. We're going to get 12. So sorry. Divided by 41. All of a sudden it jumped to negative 15 over 5, which makes no sense. So 12 over 41 will be equal to 0.2926. So we could, put that at 0.29. Very interesting. All right. I think I copied and pasted because I tend to do that, and then I didn't fix it. So, all right. So there's our answer right there at 0.29. That would be our Z-score. All right, let's look at part B. So for B, we are at what cholesterol level corresponds to the 90th percentile, the level at which treatment may be necessary. All right, so the 90th percentile would be, if we want to look at percentages, right? The 90th percentile, that's like 90%, right? Same, it's wording, but it's the same thing. And that would be the same thing as 0.90. So what we're going to do, we want to figure out what cholesterol level corresponds to that. So we're going to use our Z-score table and work it backwards. So I need to find the closest number I can to 0.9. So this one's a little bit easier to see. So I want 0.90. So I'm looking. I've got a 0.8997. And I have a 0.9015 right there, because then it goes to 0.932, so they're getting bigger. So which one's closer to 0.90? Well, this one's closer than this one by just a little bit. The 0.8997 is slightly closer than 0.9015. So, and I could figure that out for sure. I could take 0.9 minus 0.9 minus 0.8997 and 0.9 minus 0.9015, and this would get me the smaller amount. So to find the Z-score that I'm looking for, I'm going to take and go over here. That's at 1.2, and I'm going to go up at 0.08. And that'll get me 1.28. So we're working our stuff backwards. So the closest is 0.8997, which gets us a Z of 1.28. So in this case, we were finding the actual Z-score. So let me show you one more time, just in case you were stuck a little there. The 0.8997 goes up and goes over, so 1.2, 0.08, that's 1.28. All right, now, what they asked was what cholesterol level corresponds to the 90th percentile, the level at which treatment may be necessary. So that 1.28 means it's about 1.28 standard deviations above the mean. Now our mean for the cholesterol level we're going to add our mean of 178, so this is the mean, and we're going to do 1.28 times the standard deviation. Standard deviation is 41. So we've got 1.28. Oh, that didn't go in right. So 1.28 times 41. This will get us 178 plus 52.48. And that'll get us 230.48, which we will round up to 230.5. So for the 90th percentile, you're looking at a cholesterol level of 230.5. Okay, so we're working this one a little bit backwards. All right, last question. So does it make sense? So my height puts me in the 37th percentile for my gender. Now this is not actually me, this is just the statement. Which means my height has a negative standard score. So it puts me in the 37th percentile for my gender, which means my height has a negative standard score. Does that make sense? Well, remember that 50% at your mean, 50% and above will be positive, and 50% and below will be negative. Well, 37th percentile is below 50%, so this makes sense. 37% is below 50%, which is where our mean is, right? So it will be negative. All right. All right, so that's the end of the material for this exam coming up. So I've got a couple of things to just talk about. You make sure you do your homework. You also now have that activity I talked about when we did standard deviation, where you will do the standard deviation on the front. Down at the bottom, so you've got to find the mean, do the standard deviation. I've already given you the table. And then you've got to find the range rule of thumb to estimate the standard deviation. And then on the back, you're doing an activity with regard to the 68, 95, 99.7 rule. You're going to use the standard deviation that you find over here and the mean that you find over here. I've already given you a number line. You'll take your mean that you find and subtract your standard deviation 3 times to find the numbers here. And you'll add it to the mean 3 times this way to find the numbers here. Then you're going to figure out which of the data points in the list are within 1 standard deviation away from the mean. So whatever range of values you find, let's say our standard deviation, this is not the answer, but if it's between 20 and 40, all right? If it was that, then we would come over here and find the numbers between 20 and 40, and we would list them there. And then let's say our next one is between 10 and 50. If that's still not the second standard deviation, then we would go to the list and list all of the ones that are between the 10 and 50. Those are not the answers to this. I'm just giving you an example. And then you do it again for the third standard deviation, okay? So this will help, I think, solidify the standard deviation and that 68, 95, 99.7 rule. So you need to work on that. And then also you have your exam review. So remember, it's worth a daily quiz grade. It's up to 5 bonus points on your exam. You want those bonus points because it is the biggest chunk of your grade comes from your exams. You need to work it neatly in an order on separate paper, just like you did the first one. Submit it as a single PDF document into the folder for your D2L, in D2L before you take the exam. All right, so there's the questions, and you've got a key back here. Key doesn't give you all of the work. I want to see work when you turn it in. You don't get credit for just slapping down the answer key. So make sure you're showing your work to find the values. All right, and then start working on studying for the exam. There will be an exam review video that you can watch to help you with that.